In a world dominated by traditional fuel engines and emerging electric vehicles, one company is quietly preparing to rewrite the rules of transportation. BYD, short for Build Your Dreams, may not be a household name for everyone, but its influence is undeniable. As the world's largest producer of lithium-ion batteries, BYD has been a silent powerhouse, driving advancements in green technology and reshaping the automotive landscape. Now, BYD has unveiled something extraordinary, a breakthrough innovation that could change the way we think about energy and mobility forever. A water-powered engine. Yes, you heard that right. An engine that harnesses the potential of water to drive vehicles, paving the way for a cleaner, greener future. The concept sounds like science fiction, but BYD's innovation is grounded in science and ambition. This groundbreaking engine doesn't burn water as fuel. Instead, it uses an advanced process known as hydrogen fuel cell technology. By splitting water into hydrogen and oxygen using electricity, BYD's engine captures hydrogen to power vehicles, while releasing oxygen harmlessly into the air. This method, known as electrolysis, has been a dream for environmentalists for decades. And BYD is turning that dream into reality. The only emission? Pure water vapor. No harmful gases, no carbon footprint, just clean, sustainable energy. This ambitious leap forward comes under the leadership of Wang Chuanfu, BYD's unconventional and visionary CEO. Renowned for his lifetime commitment to green energy, Wang's accolades include the Zayed Future Energy Prize in 2014. Under his stewardship, BYD has developed electric vehicles, solar panels, and energy storage systems, consistently pushing the envelope in sustainable technologies. But Wang's newest venture, a water-powered engine, has the potential to dwarf all previous achievements. He envisions a world where this innovation drastically reduces global carbon emissions and eliminates our dependence on fossil fuels. Could this bold move mark the dawn of a new era in transportation? The concept of using water as fuel might sound like the stuff of science fiction, but BYD's hydrogen fuel cell technology firmly grounds this vision in established science. The process begins with electrolysis, where electricity splits water molecules into hydrogen and oxygen. The extracted hydrogen is then stored and utilized as the vehicle's primary energy source. Finally, in the fuel cell, hydrogen reacts with oxygen to produce electricity powering the vehicle. The entire process is not only efficient and sustainable, but also remarkably clean, emitting nothing but water vapor into the environment, a true game-changer for green energy. Despite its groundbreaking innovation, the Terrafugia transition faced significant challenges that ultimately hindered its widespread adoption. With a price tag exceeding $300,000, the vehicle was more of a luxury item than a practical transportation solution for everyday consumers. This high cost was largely driven by the sophisticated technology and specialized materials required to give the transition its dual capabilities, functioning as both a car and an aircraft. The complexity of the design demanded advanced engineering, resulting in high manufacturing costs, making the vehicle financially inaccessible for most people. Beyond the price, the transition also faced significant regulatory hurdles. Like Taylor's Aerocar, the transition had to meet a unique combination of automotive and aviation standards. Navigating this bureaucratic landscape was no easy task, as the vehicle needed to comply with both road safety and aviation regulations, a rare and complicated intersection that added layers of approval processes and delays. In the aviation sector, for example, safety standards for aircraft are rigorous, requiring comprehensive crash testing, maintenance, and certification. On the road, the transition needed to meet automotive regulations, which include crash safety, emissions, and driving performance standards. This combination of complex, often conflicting regulations made it a monumental task for Terrafugia to gain the necessary approvals to bring the vehicle to market. In addition to regulatory and cost challenges, the technical complexity of designing a vehicle that could reliably and safely switch between driving and flying also posed significant difficulties. Engineers had to ensure that the transition could perform optimally in both modes, on the road and in the air. This involved extensive testing, adjustments, and iterations to make sure the car's conversion from one mode to the other was both seamless and safe. Ensuring that the transition could take off and land reliably, drive safely on regular roads, and withstand the stresses of both environments required groundbreaking engineering work and presented considerable obstacles. These challenges, while significant, were not in vain. They helped pave the way for future developments in the flying car industry, offering valuable insights into the practicalities and limitations of such technology. And while the transition may not have been a mass-market success, it laid important groundwork for the next wave of transportation innovation. One of the most exciting aspects of the current shift in transportation technology is the growing interest in alternative energy sources, particularly water-powered engines. As we look forward to more sustainable forms of transportation, the potential of water-powered engines offers a significant leap forward. Water-powered engines, often powered by hydrogen extracted from water, could drastically reduce our reliance on fossil fuels, offering a cleaner and more efficient alternative to traditional internal combustion engines. Hydrogen-powered engines produce only water vapor as a byproduct, making them a truly zero-emission solution. This is an immense advantage over conventional gasoline and diesel engines, which emit harmful pollutants that contribute to climate change and air pollution. By harnessing the power of water, these engines offer a cleaner and greener alternative, with the potential to significantly reduce the carbon footprint of transportation on a global scale. One of the key reasons water-powered engines matter is their ability to address the growing concerns about climate change and environmental degradation. As the world continues to face the consequences of pollution and carbon emissions, there is an urgent need to develop sustainable transportation solutions. Water-powered engines could be a game-changer, offering a practical way to reduce the environmental impact of vehicles while still providing the same performance and reliability that drivers expect. Another important factor is the energy efficiency of water-powered engines. Unlike traditional gasoline engines, which lose a significant amount of energy in the form of heat, water-powered engines can operate at a much higher efficiency, converting more of the energy from the fuel into usable power. This leads to improved fuel economy and lower operational costs over the life of the vehicle. Additionally, because hydrogen can be produced from renewable sources such as wind or solar energy, water-powered engines could potentially be powered by completely clean energy, further reducing their environmental impact. In addition to environmental benefits, water-powered engines could also reduce the strain on global oil supplies. As demand for fossil fuels continues to grow, prices rise and supplies dwindle. Shifting to hydrogen and water-based fuels could help reduce dependence on oil, offering a more sustainable and secure energy future. By using abundant resources like water, we can create a more resilient and diverse energy landscape, reducing geopolitical tensions tied to oil production and distribution. Ultimately, water-powered engines offer a glimpse of a cleaner, more sustainable future in transportation. While significant challenges remain, such as the cost of technology development, infrastructure for hydrogen production and distribution, and regulatory approval, water-powered engines could revolutionize how we think about energy and mobility. With continued research and innovation, water-powered vehicles could become a mainstream solution, helping to address some of the world's most pressing environmental and energy challenges. BYD's advancements in hydrogen fuel cell technology are not just theoretical. The company is already in advanced stages of research and development, making the dream of water-powered vehicles closer to reality than ever before. While the road to widespread adoption will require overcoming challenges like infrastructure and cost, the potential of this technology to revolutionize the automotive industry is undeniable. As the automotive world watches, BYD is taking bold steps toward a future where vehicles leave nothing behind but water vapor. Could this innovation dethrone traditional combustion engines and even battery-powered EVs? For years, the automotive industry placed its bets on battery-powered technology. Developers poured resources into enhancing battery efficiency, extending lifespans, and building electric vehicle (EV) infrastructure. BYD, led by visionary CEO Wang Chuanfu, emerged as a global leader in this field. With backing from Warren Buffett and a staggering 2.4 million new car insurance registrations in 2023, BYD secured its position as China's top automotive brand, commanding an impressive 11% market share. Yet beneath this success lies a surprising twist. Wang Chuanfu, long a champion of battery-powered transportation, is quietly pivoting toward a bold new frontier: hydrogen fuel cells. This unexpected shift is not just about exploring alternatives, it represents a calculated response to the limitations of batteries and the urgent demand for sustainable solutions. Hydrogen fuel cells, powered by renewable sources like water, are increasingly seen as the next big leap in clean energy technology. Industry experts hail their advantages: superior energy density, faster refueling times, and potential applications in heavy-duty sectors such as trucking, buses, and aviation. Could BYD, the giant that championed EVs, now lead the charge in a hydrogen-powered revolution? Wang Chuanfu's history as a vocal advocate for batteries and solar-powered transportation is well known, and his company has invested heavily in EV infrastructure. Yet recent reports hint that Wang has been quietly diverting substantial resources into hydrogen research and development. While BYD has remained tight-lipped, rumors swirl about a prototype already in the works, one that could fundamentally change the automotive industry as we know it. Hydrogen fuel cells offer a tantalizing vision of the future. They use electrolysis to split water into hydrogen and oxygen, providing a clean, renewable energy source. Unlike traditional combustion engines that emit harmful pollutants or batteries that rely on rare earth minerals, hydrogen fuel cells emit only water vapor. For a CEO like Wang Chuanfu, who has always prioritized sustainability, this aligns perfectly with his vision of a greener planet. Hydrogen fuel cells aren't just a greener option, they also promise significant practical benefits over battery technology. These systems can deliver greater energy density, meaning vehicles can travel farther on less fuel. They also refuel much faster than batteries recharge, an edge particularly important for commercial fleets and long-haul transportation. For BYD, this technology can dramatically improve vehicle efficiency and performance. Imagine increasing your car's fuel efficiency by up to 35%, whether on city streets or highways. For the average driver, this could translate to annual savings of around $897. Multiply those savings across a household with multiple drivers or a business managing a fleet of vehicles, and the numbers become truly transformative. A company operating 50 vehicles, for instance, could save nearly $45,000 annually, a game-changing reduction in operational costs. Beyond economic savings, the environmental impact of water-powered engines is staggering. Traditional gasoline-powered vehicles emit harmful pollutants that contribute to global warming and degrade air quality. In contrast, BYD's water engine technology not only eliminates these pollutants but even adds oxygen to the environment during its combustion process. For a world grappling with climate change, this innovation couldn't come at a better time. By slashing the carbon footprint of BYD vehicles, the company is setting a new standard for sustainable transportation, one that could inspire other automakers to follow suit. Now, what's next for BYD? As BYD continues to expand its product line and innovate, all eyes are on Wang Chuanfu and his next move. If the company's rumored hydrogen prototype proves viable, it could redefine the future of transportation. With a proven track record of turning ambitious ideas into reality, BYD has the potential to lead the global shift toward hydrogen-powered mobility. BYD's groundbreaking water-powered technology promises to make this a reality, offering a cleaner, greener, and more efficient alternative to traditional gasoline engines. But it's not just about reducing emissions. This innovative solution delivers benefits that go far beyond the environment, revolutionizing how vehicles perform and last. Traditional gasoline engines suffer from inevitable wear and tear. The more fuel you burn, the harder your engine works, causing carbon buildup that hampers performance, reduces efficiency, and can even lead to engine failure over time. But BYD's water-powered engines turn this paradigm on its head. Using water as a fuel supplement improves engine efficiency by interacting with the combustion process. Hydrogen extracted from water not only enhances engine power, but also actively cleans carbon deposits, preventing future buildup. This means smoother performance, better fuel efficiency, and an engine that stays healthy for the long haul. Drivers will notice immediate benefits, including quieter rides, fewer vibrations, and smoother gear shifts, making every journey more enjoyable. Moreover, water-powered engines run cooler. Traditional engines often overheat, leading to wear and performance issues. Water's cooling properties keep BYD engines operating at lower temperatures, reducing stress on components like pistons, rings, and valves. This heat reduction extends engine life, lowers maintenance costs, and minimizes the waste heat that contributes to global warming. The financial implications are just as compelling. Imagine boosting your vehicle's mileage by up to 35%. For the average driver, this translates to savings of nearly $900 per year. Multiply that across multiple drivers or a fleet of vehicles, and the numbers skyrocket. A business with 50 vehicles, for instance, could save tens of thousands annually. Environmentally, the advantages are undeniable. Unlike gasoline engines, which spew harmful pollutants into the air, BYD's water-powered technology emits only water vapor. This not only slashes the carbon footprint of every vehicle, but also adds oxygen back into the atmosphere during the combustion process. It's a win-win for drivers and the planet. As revolutionary as BYD's water-powered engines are, the road to widespread adoption isn't without its obstacles. One of the biggest challenges lies in the process of converting water into hydrogen. Electrolysis, splitting water into hydrogen and oxygen, requires significant amounts of electricity. Transporting and storing hydrogen adds another layer of complexity. Hydrogen gas, while efficient as a fuel, is notoriously difficult to handle. Losses occur during compression, transportation, and storage, with energy efficiency in these processes rarely exceeding 37%. This raises costs and reduces overall system efficiency. Safety is another major concern. Hydrogen is highly flammable, and even small leaks can pose serious risks of fires or explosions. To address this, BYD must design robust, leak-proof storage tanks and implement rigorous safety protocols. Drivers may also need specialized training to handle hydrogen safely, adding another hurdle to mainstream adoption. Despite these challenges, BYD is determined to forge ahead. Hydrogen fuel represents a bold and necessary leap toward a sustainable future. Wang Chuanfu, the visionary behind BYD, envisions a world where hydrogen-powered vehicles coexist with electric cars, addressing gaps where batteries fall short, such as in long-haul transportation and heavy-duty vehicles. The journey to perfecting water-powered engines may be complex and costly, but BYD's relentless innovation has already reshaped the automotive industry once with electric vehicles. Could hydrogen be their next big breakthrough? Stay tuned as we explore how BYD plans to overcome these challenges, refine its water-powered technology, and deliver a solution that could revolutionize transportation forever. This is more than just an evolution, it's a revolution. Don't miss what comes next. Hydrogen is one of the most promising clean energy solutions, offering a potential pathway to a greener future. However, hurdles like storage, transportation, and safety continue to cloud its widespread adoption. Companies like BYD are tirelessly pushing the boundaries of innovation to address these obstacles. Yet, even with their relentless pursuit of solutions, hydrogen-powered vehicles face challenges that make them less practical compared to other fuels, at least for now. But the story takes an unexpected and darker turn. Brace yourself for a revelation that intertwines technological ambition with intrigue and conspiracy. The concept of water-powered engines isn't new, and one of the earliest pioneers was Stanley Meyer in the 1990s. Meyer claimed to have developed a revolutionary engine that could run on water by splitting it into hydrogen and oxygen. However, his sudden death on March 20, 1998, left the project shrouded in mystery. According to reports, Meyer died after running out of a restaurant during a meeting with two Belgian investors, allegedly exclaiming, "They poisoned me." His brother suggested Meyer was targeted by oil industry stakeholders who feared the disruption his invention could bring to traditional energy markets. While some media outlets dismiss these claims as conspiracy theories, the ambiguity surrounding Meyer's death adds a layer of intrigue to the history of water-powered technology. Fast forward to today, and BYD's ambitions could reignite this controversial dream. Led by visionary Wang Chuanfu, the company has steadily climbed to the forefront of sustainable innovation, excelling in electric vehicles, batteries, and renewable energy. If BYD successfully commercializes water-powered technology, it could revolutionize not just the automotive industry, but also the global energy landscape. The implications of hydrogen-powered engines are nothing short of revolutionary. Environmentally, they represent a groundbreaking shift towards sustainability, emitting only water vapor and eliminating harmful pollutants. making them a true zero-emission solution. Economically, the widespread adoption of this technology could disrupt traditional energy markets, reducing reliance on fossil fuels and redefining how we power our transportation systems. On the technological front, advancements in hydrogen storage and transportation hold the potential to extend far beyond vehicles, unlocking new possibilities for energy grids, industrial processes, and more. Together, these factors position hydrogen as a transformative force in the journey toward a cleaner, more sustainable future. Despite its potential, hydrogen technology is far from perfect. Converting water into hydrogen requires electrolysis, an energy-intensive process that raises costs and reduces overall efficiency. Transporting hydrogen adds another layer of complexity, as gas or liquid forms require compression and refrigeration, leading to inevitable energy losses. Safety concerns also loom large. Hydrogen is highly flammable, and leaks could lead to catastrophic accidents. Developing robust storage systems and comprehensive safety protocols will be crucial for mass adoption. BYD's ambitions don't stop at land-based vehicles. The futuristic XPeng X2, a flying car concept, hints at a world where transportation evolves vertically and sustainably. Equipped with vertical takeoff and landing, VTOL technology, autonomous navigation, and advanced electric propulsion systems, the X2 represents the next frontier in mobility. Unlike traditional aircraft, the X2's compact design allows it to take off and land in tight urban spaces, making flying cars a practical solution for congested cities. Its autonomous systems simplify operation, letting AI handle navigation, obstacle avoidance, and real-time adjustments, ensuring a safe and seamless experience. Whether through water-powered engines or airborne vehicles, BYD's commitment to innovation is setting the stage for a transportation revolution. The challenges are steep, and the history is fraught with controversy. But the potential rewards, a cleaner planet, efficient transportation, and a new era of technology, are too significant to ignore. Stay tuned as we uncover how BYD plans to navigate the obstacles, rewrite the rules of energy, and usher in a new chapter of sustainable mobility. The future isn't just around the corner, it's taking flight. The XPeng X2 represents a monumental leap toward the future of sustainable, innovative transportation. Powered entirely by electricity, it eliminates the need for fossil fuels, positioning itself as a green alternative to traditional gas-powered vehicles and aircraft. With zero emissions during operation, the X2 significantly contributes to reducing air pollution and shrinking the carbon footprint, aligning perfectly with global efforts to combat climate change. Inside the X2, luxury meets innovation. The high-tech, user-friendly interior is thoughtfully designed to make every journey smooth and enjoyable. State-of-the-art displays provide real-time updates on speed, altitude, and navigation, keeping passengers informed and in control. The cabin is equipped with plush seating and an intuitive control system that balances functionality with modern style, ensuring comfort whether driving or flying. The X2's structure is a marvel of engineering, utilizing lightweight, high-strength materials to enhance both performance and durability. These materials reduce the vehicle's weight without sacrificing strength, which is critical for efficient flight and smooth driving. Designed to endure the stresses of both road and air travel, the X2 offers reliability and long-lasting performance, making it a trailblazer in the realm of flying cars. The X2 is more than a vehicle. It's a glimpse into the future of personal mobility. With its dual capabilities to seamlessly transition between driving and flying, combined with its advanced technology and environmental benefits, the X2 stands as a groundbreaking innovation. It captures the imagination of those dreaming of a cleaner, faster, and more efficient way to travel. When will the X2 become a reality? Since its announcement, the XPeng X2 has generated immense excitement, with many eagerly awaiting its release. While an official launch date for the general public is yet to be confirmed, XPeng Motors has shared insights into its roadmap for making the X2 a reality. According to XPeng's vice chairman and president, the X2's recent public demonstration in Dubai marks a significant milestone in advancing flying cars on the global stage. Behind the scenes, XPeng Aero HT, the division responsible for the X2, has spent years refining its technology to ensure it meets rigorous safety and performance standards. Prototypes have undergone extensive testing to address technical challenges and perfect the vehicle's dual driving and flying modes. One of the most significant obstacles to bringing the X2 to market is obtaining regulatory approval. Flying cars must meet strict aviation and transportation standards set by global authorities. XPeng Aero HT is actively collaborating with regulators to ensure the X2 complies with all necessary certifications and safety requirements. This meticulous process involves detailed assessments and approvals, which are essential to guarantee the vehicle's legality and reliability. The XPeng X2 embodies the next chapter in personal transportation, offering a sustainable, efficient, and futuristic way to travel. While its arrival for public use is still on the horizon, the groundwork laid by XPeng Aero HT signals that the dream of flying cars is closer than ever. Soon, this revolutionary vehicle could transform not just how we travel, but also how we envision mobility itself. There's exciting news for those eagerly anticipating the XPeng X2. XPeng Motors has hinted at the possibility of pilot programs and pre-orders ahead of a full public release. These programs will allow a select group of customers to experience the X2 firsthand, providing valuable real-world feedback. By involving early adopters, XPeng can refine the X2's design and functionality, ensuring it meets customer expectations before a broader rollout. While a specific release date hasn't been confirmed, industry experts speculate that the X2 could arrive sooner than anticipated. The timeline depends on several key factors: completing regulatory approvals, the success of pilot programs, and the readiness of production facilities. XPeng remains committed to thoroughly testing the X2 to ensure it's safe, reliable, and ready for everyday use. The XPeng X2 represents a monumental leap forward in personal transportation, seamlessly combining driving and flying capabilities. It's no wonder this revolutionary vehicle has captured global attention, igniting the imagination of countless enthusiasts. While the XPeng X2 is groundbreaking, it's far from the first attempt to create a flying car. The idea has fascinated innovators and dreamers for decades, and each generation has brought unique approaches and challenges. To truly appreciate the X2, we must look back at the pioneers who laid the groundwork for today's advancements. One of the earliest serious attempts came in the mid-20th century with the Moulton Taylor's Aero car. Taylor envisioned a vehicle that could transition seamlessly between road and air, offering a practical solution to transportation challenges. His dream was bold, ambitious, and revolutionary for its time. In the 1950s, Taylor developed the Aero car, a hybrid vehicle designed to be both a car and an airplane. It could drive on roads like a conventional vehicle and transform into an aircraft when needed. Innovative design. The Aero car featured a streamlined body for road use, complete with folding wings and a detachable tail. These components could be stored in the back of the vehicle and assembled in minutes, transforming the car into an airplane. Performance. Powered by a 100-horsepower engine, the Aero car could reach speeds of 50 mph on the road and 100 mph in the air. It was a gentle and smooth flying machine, offering versatility few vehicles could match. Despite Moulton Taylor's groundbreaking vision, the Aero car faced formidable challenges that prevented it from achieving widespread success. Safety concerns were a major obstacle. Flying cars inherently pose significant risks, including mechanical failures and stability issues in the air. While Taylor integrated safety features into the Aero car's design, the technology of the 1950s simply wasn't advanced enough to fully mitigate these dangers, leaving safety a critical concern for potential users. Regulatory complexities further hindered Aero car's development. As a hybrid vehicle, it had to comply with both automotive and aviation regulations, an intricate and often conflicting web of standards. Navigating these requirements proved to be a daunting task, with Taylor struggling to secure the necessary approvals from authorities. Lastly, high costs are a significant barrier. The expense of developing and manufacturing the Aero car was prohibitively high, making it financially inaccessible for the average consumer. This limited its potential market and stifled its commercial viability. While the Aero car was a bold and innovative attempt at redefining transportation, these insurmountable challenges ultimately kept it grounded, serving as a lesson and inspiration for future advancements in flying car technology. The Aero car's story is a testament to human ingenuity and determination, even in the face of immense challenges. While it never became a commercial success, it inspired generations of inventors and engineers to keep pushing the boundaries of what's possible. Now the XPeng X2 stands on the shoulders of these early innovators, equipped with cutting-edge technology, advanced materials, and regulatory expertise. It's more than a flying car. It's a realization of dreams that have spanned decades. As XPeng Motors continues to refine the X2, we inch closer to a future where flying cars are no longer the stuff of science fiction, but a practical and sustainable reality. The sky, quite literally, is no longer the limit. The vision of flying cars didn't end with Moulton Taylor's Aero car. It evolved and gained momentum in the 21st century, thanks to advancements like the Terrafugia Transition. This innovative vehicle, developed by Terrafugia, a company founded by MIT graduates, aimed to turn the dream of a flying car into a practical reality. The Terrafugia Transition was designed as a roadable aircraft, seamlessly blending the functionality of a car with the capability of an airplane. On the road, it resembled a compact sports car, complete with retractable wings folded neatly against its body. Equipped with standard automotive features, it could navigate regular streets with ease. However, with the press of a button, the wings deployed in under 30 seconds, transforming the vehicle into an aircraft ready for takeoff. Powered by a 100-horsepower engine, the Transition provided sufficient performance for both driving and flying. Despite its groundbreaking innovation, the Terrafugia Transition faced significant challenges that ultimately hindered its widespread adoption. With a price tag exceeding $300,000, it was more of a luxury item than a practical transportation solution for everyday consumers. The high cost stemmed from the sophisticated technology and specialized materials required to enable its dual functionality as both a car and an aircraft. In addition, like Taylor's Aerocar, the Transition had to meet stringent automotive and aviation regulatory standards, navigating a complex and bureaucratic approval process. The technical complexity of designing a vehicle that could seamlessly switch between driving and flying modes also posed a monumental challenge. Extensive testing and engineering refinement were needed to ensure both safety and optimal performance in each mode. These obstacles, while significant, provided valuable insights and paved the way for future advancements in the realm of flying cars. However, unlike Taylor's project, the Terrafugia Transition made notable progress. It became the only light sport aircraft to undergo crash testing, incorporating a full vehicle ballistic parachute system and the ability to drive in adverse weather conditions. The company showcased the vehicle at various industry events, sparking interest from aviation and automotive sectors alike. The Transition's development not only brought flying cars closer to reality, but also contributed valuable advancements to both fields, offering insights into the challenges and possibilities of this hybrid technology. As we now marvel at the XPeng X2, it's clear that flying cars have transitioned from a far-off dream to an emerging reality. The X2's cutting-edge features, environmental benefits, and practical design suggest a bright future for personal mobility. Unlike its predecessors, the X2 represents a leap forward, paving the way for a new era of transportation. What are your thoughts on this revolutionary flying car from China? Share your opinions in the comments below, and don't forget to like, share, and subscribe for more exciting insights. Also, check out the next video appearing on your screen. You won't want to miss it.